All right, hello everyone, this is Mr. Coach. I'm going to go back over the notes from today in a little bit slower and in more detail. Here we go, we have a function. It's given this function that f of x is 2x cubed over 3 minus 2x. Find input 3, so you simply just plug 3 in there. I'll do it with my calculator. Let's see here. 2 times 3 to the third power divided by 3 minus 2 times 3 to the second power is 0. So input 0, output, and that's a point on the graph, so this point is x, y. Finding the derivative, well, I pull this down, and I have, originally I'd have 6 x squared, but don't forget it's being divided by 3 minus 4x. So 6 divided by 3 is 2, 2x squared minus 4x. F prime of 3 means we take 3 now and we plug it into this equation here and here. And if I do that math, 2 times 3 squared minus 4 times 3, we have 6. Now this 6 becomes, of our equation, y minus y1 and x minus x1, it becomes the slope of our equation here. And then I can plug in a point there and simplify it into that. Some people like to put their 6 right here at this slope and then plug in a point there. You'll still get the same answer. The idea is you are plugging in this point. This is the point which gets plugged in. Number 2, implicit differentiation. We find the derivative with respect to x. So this would be 2y with a dy dx. And again, if I'm taking the derivative with respect to x, when I do the chain rule of y, I have dy over dx. Plus, this is product rule, left function, right function, left dy plus right d left. And when you take the derivative of x squared, it's 2x. And then you don't need to put anything on it because you're left with dx, ddx of x, which is 1, that's 5. Bring these together, factor this out, put both of these on the other side. The 5's already there. This term went over there. Divide that out here and here. You could factor this bottom, but there's nothing that would factor out, so I'm going to leave it like that. On number 3, it says, given x, tell what the value of the derivative is. At -2, a tangent line would be positive. At -1, a tangent line would be 0. At 0, a tangent line would be negative. At 1, there's a sharp point here, so there's multiple tangents that you could do. There is no derivative. And at 2, there is no place to draw a line. There's no derivative. Positive, 0, negative, undefined, undefined. Number 6 has a circle, and it asks you to find the change in the radius with respect to time. And it tells you that the area with respect to time is 7 and the radius is 3. Well, here's our equation. This equation relates all of this. And if I take d dt of both sides, I have dA over dt. Here I bring this down, and 2 times pi is 2 pi. And change it from 2 to 1, and then dr dt. Now I have an equation where I'm asked to solve for this. Find dr. All right, well, I know what this is. This is 7 because I'm told this. 2 is 2, pi, r is 3 because I'm told this. And I'm asked to find this. Well, everything gets divided over this way. I start with 7 feet squared per second. I divide by 2 pi. I divide by 3 feet. And this was feet squared.
Alex Walters, pick up a call on Park 1. Alex Walters, pick up a call on Park 1.
And this was feet here, so I have 2 feet, 1 feet. One of them cancels off. I'm left with feet per second. 7 pi divided by, or 7 divided by 6 pi. And that's how the radius is changing. The area is growing by 7. Well, that means the radius is growing by this number here. And what is that number? If you had to do it on a calculator, you would have to type in 7 divided by 6 pi, all in parentheses, or 7 divided by 6 and divided by pi, 7 divided by 6 pi, 7 divided by 6 and divided by pi, but you can't do 7 divided by 6 pi. Look how those numbers are different. The first two mean you're dividing by 6 and pi. The bottom one tells the calculator to divide by 6, then separate that. What your calculator is doing on the last step is doing that right there. So make sure you type it in this way if you need a decimal. All right, hope this helps with your notes.